What are we working on today?
Do you want me to send you a picture of it?
I'm sorry, what?
Do you want me to send you a picture of it?
Only if you can't verbalize it. If you can verbalize it, we can do that. If it's graphs, then you probably should send me a picture.
There's some graphs on it.
Okay. Go ahead and send me a picture if you like.
Okay.
Need my email? What's the general topic we're dealing with today?
Finding length of arcs.
Okay.
What's the email again?
Well, send it to my email address. I'll write it. David Cowan, 1949 at Gmail.
Okay. Okay, I sent it.
Okay. Tends to take a little bit of time. Did you put the 1949 in there?
Yeah, I did.
Okay. Might take 30 seconds or so to get here. Do you have a problem you can verbalize while we're waiting for it?
Yeah.
Okay.
It says use the given information to write the standard equation for the circle. In number 14, the information is the center is 2, -3, and a point on the circle is 7, -8.
Okay. What's the general format for the equation of a circle?
X plus.
It's always minus.
Oh, x minus. Yeah. And then plus y minus. And then equals the radius squared.
Okay. So they've given us the center. So that allows us to fill in that. So it's x minus 2 squared plus, what's this part going to be?
Y plus 3 squared equals,
Yeah, we don't know the radius yet.
yeah.
But they also give us a point on the circle. Now, when you have the equation of a circle, it's only for points that are on the circle. Okay? So if this point is on the circumference of the circle, then I know that when x is 7, y is minus 8.
Okay.
Okay, so I can plug that in. Now I have an equation with only one variable, and I'm going to be able to solve for it. Okay, help me finish this.
Okay. Hold on. I don't know how to start
What's
that.
7 minus 2?
Oh, 5, and so 25 plus, or minus 20, or no, plus 25
Good.
equals R.
R
So
squared.
50, R squared, so 50 equals R.
No, 50
R
equals R
squared.
squared. So what was their question? Did they want to know the radius of the circle or the area or what?
They just wanted to write the equation.
Okay, well then R squared is equal to 50. So
Mm-hmm.
now we know that y minus 2, in other words, we go back and put in what we know to be the center of the circle. Is it 2?
Mm-hmm.
Plus, excuse me, x minus 2 plus y plus 3 squared, and r squared is 50. So there is the specific equation of this circle.
Okay.
Okay. All right. What else you got?
Um, it says it's the same kind of problem, and it says the center is m comma n, and a point on the circle is m plus h comma n plus k.
Okay. Let's go through the exact same process. What's the general equation of a circle?
X minus h squared plus y minus k squared equals r squared.
Okay, so we're going to go through exactly the same process. We know the center is there. So the first thing I can say is what?
X minus m squared plus y minus n squared equals r squared.
Okay. Now, since they've told me that this point is on the edge of the circle, let's
Mm-hmm.
plug that in for x, that in for y, and see what we get.
Okay, so
You with me?
yep.
What's the rest of it?
N plus k minus n squared.
Now simplify. What is this quantity here going to be?
M squared plus k squared.
Now, notice we got an m plus k minus m.
Oh, so just k
Just
squared.
k squared. And this one over here?
It's it's k squared.
So now I can say that 2k squared equals r squared. And what did they want for this as an answer?
They want the standard equation.
Okay. So if r squared equals 2k squared, then let's write it in standard format. X minus m. We don't know what m is. We don't know what k is. But they're looking for this kind of an answer. And instead of r squared, I'm going to write 2k squared.
Okay.
And that would be the general format. As long as we knew what m, n, and k were, we would have a standard equation of a circle.
Okay.
They purposefully don't tell us what it is,
Mm-hmm.
just to make us better. Okay, what else?
It has a circle.
Oh, I didn't get your email.
Oh, you didn't?
No. Make sure you send it to David Cowan, 1949 at gmail.com.
19.
Try sending it one more time.
Okay. Okay, I sent it again.
Okay. What else you got verbally that we can talk about until we're waiting for that?
It's so there's a circle with a right angle in the middle of it. Not on a graph, just a circle.
Ah, sector. And by red angle, you mean something like that?
Yeah.
Okay.
And then it has a 3 on the radius.
Okay.
And then it just points A and B, or where the right angle meets the outside.
Ah, A and B, and this is a right angle?
Yep.
Okay. What's their question?
Find the length of AB, of arc AB.
Okay. There's a formula for this, but I think it's worth understanding it without knowing the formula.
Mm-hmm.
The key here is that when you know the radius of a circle, you know everything about it. You know its area, you know its circumference. So what's the circumference of this circle? What's the general formula for circumference?
2 pi r.
This circumference is going to be what?
2 times 3.14 times 3.
6 pi. Right?
Yeah.
Okay. Well, if the entire circumference is a measurement of the entire arc length, which it is, how much of the arc length do we have between A and B?
Of course.
Yeah. Why? Because 90 over 360 is 1/4.
Mm-hmm.
So if the full circumference is 6 pi, then we're talking about a quarter of the circumference, which is 1.5 pi.
Okay. Perfect. Thank you.
Yeah, and likewise, let's talk about this problem a little bit more, because you'll run into this problem on ACT and SAT tests,
Mm-hmm.
where they're asking for the arc length or the area of this sector. So what would the area of that sector be? What's the general formula for area?
Base times height.
No, that's for a rectangle. For a circle?
I don't remember it.
Pi r squared.
Oh.
That's something you need to remember. Both the area and the circumference are two of the more important formulas you can remember.
Okay.
Notice they have the same 3 characters. Pi r squared, and circumference is you take the 2 and stick it down in front, 2 pi r.
Yeah.
So that makes it a little bit easier to remember. The trick to remembering stuff is to come up with some technique that is something other than just memorizing random letters and characters. So if the area of the full circle is pi r squared, what is it for this circle?
It's 3.14 times.
No, leave it as pi. Don't round it off.
I don't know how to do that.
Well, just substitute 3 for the radius.
Oh, okay.
So it's 9 pi. In other words, before, when we were calculating circumference, we left it as 6 pi.
Mm-hmm.
We want to do the same thing with area. You're at a point in math where I'm not sure they're doing this in your class or not, but everything higher than this, you're going to leave pi as pi. You're not going to convert it to 3.14. Whenever you convert pi to a number, you're rounding it off. You're approximating.
Okay.
You're not giving the true value of it. You're approximating it. Even if I told you pi is 3.1459, that is an approximation. Well,
yeah.
I don't want approximations. I want exact values. So the exact area is 9 pi. Well, this is how much of the total area?
A fourth.
Okay, so the area of our sector is 9/4 pi.
Okay.
That's the way you're going to do all arc lengths, because arc length is just a piece of the circumference, and areas of sectors, which are just a piece of the area of the circle.
Mm-hmm.
What else? I still did not get that email. I'm not sure what's going on.
Okay, well, there's a graph, and it says graph the equation, and the equation is x squared plus y minus 5 squared equals 121.
The way you want to start all of these problems is with the general equation.
Okay.
What's the general equation of a circle?
X squared plus h.
X minus
plus h.
Remember, it's always minus.
Plus y minus k squared equals r squared.
Okay. So in this problem, what is h?
0.
What is y? Or what is k, excuse me?
5.
And what is r?
11.
Okay. So h is the x coordinate of the center. K is the y coordinate of the center. So let's make the center right there at 0, 5.
Okay.
What's the radius of the circle?
11.
Okay, so 5 to minus 6, we're looking at a circle about like that.
Okay,
Doesn't matter if we draw it perfectly, as long as we label the center and we know what the radius is.
Mm-hmm.
All right. What else?
There's another circle like the second one we did, where it's a circle and it has AB.
What's the size of the angle?
30 degrees.
They want to know arc length or area?
Arc length.
What's the radius?
4.
What's the total circumference of this circle? What's the general formula for circumference?
2 pi r.
Okay, so in this case,
it's 8 pi.
okay. What part of that circle is that?
Is what? Oh, that's what is that?
What fraction?
30
over what? If this is a 30-degree angle, what's the angle all the way around?
360.
Okay, so it's 1/12 of the circle. You see how I'm doing that?
Yeah.
And that's what you always do. Before, the last problem was 90. Well, 90 over 360 is 1/4. It was easier to see when it was 90, but when it's 30 degrees, we have to work out this fraction. So it's 1/12 of 8 pi.
Okay.
Which is 2 pi over 3 when we simplify it. So that's the arc length, 2 pi over 3 from A to B.
Okay.
Similarly, if we wanted the area, same kind of problem. The area is pi r squared. Well, that would be 16 pi. And we're dealing with 1/12 of the area. So the area is going to be 1/12 of 16 pi, or 4/3 pi.
Okay. Thank you.
So area and arc length of sectors is very similar. You figure out what the whole circle is, and you take whatever percentage it is.
Mm-hmm.
All right. What else?
There's a circle with AB again, but the angle's 150.
Okay.
And the radius is 10.
All right. Let's have you do this one all by yourself.
Okay.
What's the first step?
The circumference C equals
In
45.
Well, you know, until you have these memorized so well that you don't have to think about them, it's a good idea to start every single problem off with the general formula. It really is. I can't emphasize that enough. And at some point in time, you won't even have to think about it. You'll know what it is. That's where you want to get to. So what's the general formula for circumference?
C equals 2 pi r.
In this case, what does that equal?
C equals 45.
The radius is how much?
The radius is 10. Oh, it's 30. Sorry, 30 pi.
20 pi. 2
25.
times 10 is 20.
Oh, yeah.
Okay, so that's the circumference of our circle. What percentage of that do we have?
You have 20 pi over
No, hold on.
360.
Hold on. This angle right here determines what the ratio is.
Okay.
So always start with that angle.
Okay, so 150 over 360.
That's the percentage of the circle we're dealing with. Notice that if this was 180, it would be half of the circle. If it's 90, it's a quarter of the circle. If it's 150, it's whatever that ratio is. And then times what?
Times
20 pi, the circumference of the whole circle. In other words, this arc length from there to there is 15/36 of 20 pi.
Okay.
If this was a 360-degree angle, we'd be talking about the entire circumference, which is 20 pi. But the fact that it's a 150-degree angle means we're only talking about 150 over 360 times 20 pi.
Okay.
Now, you can do a lot of things here. So what does this reduce to? Let's see. 20 times 15 is 300 over 36 pi. And let's see. What goes into both of those numbers? 4. 4 goes into 375 times, and 4 goes into 36.9 times. There's no equal sign, excuse me. It's 75 pi over 9 is the simplified answer.
Okay.
Now, and that's not even simplified. 3 goes into 75 25 times, so it's 25 pi over 3. There's your final simplified answer.
Okay.
This is correct, but you'd lose points because it's not simplified.
Okay.
You might not lose full credit, but you'd lose a little bit of credit. You always want to simplify your answer down as far as it'll go. And not to say that I'm going to replace pi with 3.14. I'm not. I'm going to give my answers in pi, which is what we do all the time at this stage.
Okay.
Don't convert pi to a number. What else, Jackson?
All right. I only have one more problem actually for the day.
Okay.
And it's another graph.
Okay.
And it's the equation that we have to graph is x plus 4 squared plus y minus 1 squared equals 49.
Give me the general equation for a circle.
It's x plus h squared, or x minus h squared.
Remember, it's always minus.
E plus y minus k squared.
That's always minus also.
Equals r squared.
Okay. So let's figure out what h, k, and r. If we can figure out what h, k, and r are, we'll know how to graph it. What's h?
H is 4. Or negative 4.
What's k?
1.
And what's r?
7.
Okay. That means we go to the center that's located at minus 4, 1. So there's the center of our circle.
Okay.
And we're going to draw a radius of 3. Of 7, excuse me. Like that.
Okay, perfect.
Okay? So all of these problems are the same. You have to identify what h is, what k is, and what r is, and then you can graph it. Because there's only one circle that can have this center and this radius.
Okay.
All right. Is that all you have for today, Jackson?
Yeah. Yeah, it is. Thank you so much.
Are you still going to need your 4 o'clock session on Thursday? You'll have new material?
Yeah, I will.
Okay. I'll go ahead and make this a half-hour session.
Okay, yeah, thank you
That's
so
all
much.
right. I only will charge you for what you use. And I will talk to you Thursday at 4. And thank you for letting me move that back. That gave me a little more flexibility. So.
Yeah, whatever helps.
All right. Talk to you on Thursday, Jackson.
Okay, see you. Thank you.